Okay.
All right.
Okay, number 6. Which of the following results implies that the spread decreases as the sample size decreases?
I still don't know what X is.
I know, that's why I kind of skipped it. Is it the average? That's what I want to say, but I'm not sure.
I don't know. Like even where it's like the random variable is kind of what I'm gathering from.
Oh, yeah, you're right.
What does that mean, though?
Yeah, I don't know. It's like whatever variable we're dealing with. I don't know.
Oh. Or it's the sample mean. Wait, that doesn't make sense. Researchers typically see only one value of the sample mean, and it says comma X with a little line over it. That's a sample mean?
I guess so.
Makes sense in relation to the other problem we did about the weight of the passengers, because 177.6 was our sample mean, and in the equation that we did, it shows X subtract the mean of the population. So I think X is the sample mean. At least that's what we did for that one.
Okay.
But I think that's so. If this, which of the following results implies that the spread of the sample mean decreases as the sample size increases? It's definitely not the 68, 95, 99.7 rule.
So by like when it says spread in the sample mean, does it mean like, is it talking about standard deviation or I'm confused?
I think so. That's all of things. Number 6. Yeah, number 6. So the central limit theorem says that, oh, maybe this is it. Well, the distribution of the sample means is normal when X is normally distributed or when our sample size is large. I don't know if that really.
And the law of large numbers is just like, as it gets bigger, the I forget, the like, I don't remember.
It's the sample mean will get closer to the population mean.
Okay.
So I don't see how any of those fit.
Yeah. Oh my gosh.
But I don't
This is
think
harder than I thought.
the normal distribution. I don't know if that's. I mean, that's just the. Isn't that just talking about the trend of it's kind of the shape of. I don't know. What's the spread in the sample mean decreases? So I think that does mean standard deviation decreases as the sample size increases. Let's see. So if the sample size is large, the sample mean is normally distributed. Is that maybe that
Can you
kind
say
of
that
tells
again?
me. This is when the where is that? Is when the sample size is large and the sample mean is becomes normally distributed. Well, that doesn't really. Well, that talks about sample size,
It's true.
but I don't know if becoming more normally distributed really means the spread in X decreases. It might, but I don't know that for sure.
I feel like I need to go back and see exactly what normally distributed means.
Yeah,
Let's
that's
see.
chapter 5, isn't it? Normal distribution. the normal distributed, that's just where it looks like our little applet thing, right?
Yeah.
So how does it translate? How would that could that have anything to do with this?
I don't know. The normal
I
distribution.
don't know either.
If the sample mean is getting closer to the population mean, does that mean that the spread is decreasing?
It, it could.
I don't know.
Is that the law of large numbers?
Yeah. Just trying to like find some connection.
I know, me too. I'm not very able to relate it. I'm not sure on that one. Spread in X decreases as the sample size. You know, I'm kind of leaning towards. Well, I don't know. The central limit theorem talks about having a large sample size. But so does the law of large numbers also talk about that?
Yeah.
Yeah. I kind of think it's the large numbers one.
That's what I'm leaning towards. Just because like I can't explain the other ones like at all.
No, that's the only one I can kind of make sense of because it gets closer to the population mean. Could mean it's going to be less, or its spread decreases because it's kind of getting more. I don't know. That's my best.
Yeah. That's yeah. I'm just
Okay.
gonna go with that. I don't know.
All right. Did you read that one, or did I?
I think you did.
Okay.
So scores in the quantitative portion of the GRE are approximately normally distributed with mean 150.8 and standard deviation 8.8. Use this information to answer questions 7 through 10. Diane earned a score of 160 on the quantitative portion of the GRE. What is the z-score corresponding to Diane's score? Okay, it's not too bad.
I think this is just a regular equation, right? Not with the weird square root in it.
Now I don't know. I'm confused.
The only reason I'm thinking that is because it's not talking about like a sample of the population. It's
You're
just
right,
talking
it's like one score.
per individual score.
Then it has a population mean. Does that make a difference?
For the, sorry, for what?
Because it has a population mean and not like a sample mean.
Yes. So yeah. So I think that means the first equation,
Okay.
like from last chapter or whatever. So it's per score minus the mean
Okay.
divided by standard deviation, I think.
Just want to go back and check real quick.
Yeah. Yeah. Chapter 5? Oh, yeah, it was chapter 5.
I think so. Okay, I think you're right. Yeah.
So it's
like,
her score minus the mean over standard deviation.
yeah. So I got 1.045.
Yeah, me too. Okay, great.
Cool.
All right, so number 8. What is the probability that a randomly selected student will score above 160 on the quantitative portion of the GRE? So we just select the area above that.
Yeah.
I got 0.148. I think,
Same.
yeah. Okay, awesome.
Okay. A random sample of 5 students was selected to take their GRE. What is the z-scores corresponding to the sample mean of these students' scores? So we're going to find the mean.
Yeah, so we average all those?
I think so.
3. Oh.
So for this one, do we just do the newer equation?
I think so, yeah, because we're doing a sample mean. So what I did was, yeah, just averaged all those, then subtracted it by the population mean, and then divided it by square, or 8.8 divided by the square root of 5. So there's 5 students.
Okay.
Boom.
What'd you get?
I got 2 point, rounded up at 2.338.
I got that too.
Okay. I'll stick with it.
All right.
Okay, my turn.
Yeah.
Okay, what is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem? Okay. So you just plug it into the applet.
Yeah, I got 0097.
Yeah. So should we round it to 0.010?
Oh,
I hate when this happens.
probably. I know.
I never know what to do, but I think it's got to go to 10.
Yeah, I think you're right. 010.
0.010. Yeah.
Hate this fill in the blank. It makes me so uncertain.
I know. Give me multiple choice.
Okay.
I think that's right.
Okay, suppose the mean GPA of BYU Idaho students is 3.5 and the standard deviation is 0.7. It is well known that this distribution is less skewed. A random sample of 81 students will be drawn. What is the shape of the sampling distribution of the random variable which represents the sample mean of the 81 students who are selected?
Well, I don't know. Because 81 is a pretty large. I don't know. Is that a large enough sample size to like make it normal? I don't
I
know.
think it is because I think I remember some number about like over 30 being large,
Okay.
which doesn't sound large, but I think it is.
Sounds good to me. Okay. What is the mean of the distribution of the sample means for all possible samples of size 81 that could be drawn from the parent population? What?
Okay. What's the mean?
The mean of the distribution of the sample means. Oh, I think
The mean. I'm not really understanding it.
no. This one, it says right here the mean. So this, let's see, the mean of the distribution of the sample. I think it might be the same thing as just the mean of the population, just the 4.5. So remember on the answer key for the second part,
Mm-hmm.
I think that was one of the things. I'm gonna look it up really quick, but I think it said like what is the sample means, the mean of the sample means or whatever, and it was just that. Answer key. You finding anything about it?
No, I'm just trying to look over the chapter.
Mm-hmm.
Oh, So it says the mean of the distribution of sample means is the population mean. So is it just the population mean?
I think so. So I think it's 3.5.
Okay.
Yeah, that's all I could find. Okay.
Okay. So what is the standard deviation of the sampling distribution of the random variable x, the mean of the 81 students who are selected? Okay. And that's just like standard deviation divided by the square root of the number, right?
Yeah. Think of that. So just 0.7 divided by the square root of 81. So it's just divided by 9, I guess.
Yeah.
0.078.
Yeah.
Okay.
Or 0.7. Oh yeah, I was doing it wrong. Okay.
So what is the probability that the mean GPA for 81 randomly selected BYU Idaho students will be less than 3.3? Okay. The thing is that this is that second equation
Yeah.
on the z-score divided by. We can just divide it by 13, right? Once we do
Oh
3.3.
yeah. I don't know why I did 9. I did it totally wrong.
So
Wait, so actually now I'm confused. What did you do? Just like 3.3 minus 3.5?
yeah,
And
and
then
then
divided by.
what we found at 13, because that should be the
Oh,
standard
okay.
deviation.
I don't know why I thought you said like number 13. I was like, where did that come from?
Oh, no, yeah, that doesn't
No.
make sense.
Yeah, no, you're right.
So for question 13.
So I got 0052.
Yep, me too. 0.005.
Yeah.
Okay,
All right. It's my turn.
yeah.
Okay, what is the probability that the mean GPA for 81 randomly selected BYU Idaho students will be greater than 3.3? Sweet.
The applet
Got the same thing.
995.
Wait. Oh, yeah, you're right.
You know, yeah.
995, yeah.
Okay.
All right. I'm not sure about this one.
No, me neither, but oh well. I'm submitting it. Let's see what happens. 100.
Sweet.
Yay.
Okay, cool.
Cool. All right.
Okay.
Have a
Have a
good
nice
weekend.
weekend. Bye.
Bye.